there, and thank you for joining me. Today we are looking at paper 2, a calculator paper, from the Pearson Edexcel GCSE paper from June 2024. We're going to look at the paper one question at a time, looking at the methods and solutions. Start then with question 1. It says, write the following numbers in order, starting with the lowest number. So we've got 5 different numbers. Some of them are positive, some of them are negative. I like to think of this as a temperature gauge. I like to look things vertically. So with a temperature gauge, 0 is there, and the normal numbers would go up into the positive this way. And of course, we also have on a thermometer the negative numbers, which go down this way. So if we look at what we have here and we're looking for the lowest number, well, that will be this one, -3. So -3 is the lowest. As we start going up, we find -1, so that will be the second one. That's those two. Then we're going to go past 0 up into normal numbers, so of course the smallest of those is 2, and then 4, and finally 7. 2 wants us to change 5,000 millilitres to litres. Don't forget, the word meal means 1,000, so that means that 1,000 millilitres equals 1 litre. Therefore, 5,000 millilitres equals 5 litres. And that's your answer. Question 3. Write 31 hundredths as a decimal. So we're starting with a fraction. Well, don't forget, 31 over 100 literally means 31 divided by 100. And that's what we've got to do. So if we take the number 31, in order to divide by 100, well, the decimal point is here. To divide by 100, we move the decimal point 2 places to the left, so it ends up in front of the 3, and that gives us 0.31. There's our answer. Question 4. Write down the multiple of 7 that is between 30 and 40. Well, multiples of 7 simply mean the 7 times table, so that would be 7, 14, 21, 28, 35, and there we go. There's a multiple of 7 that is in between 30 and 40. The next one will be 42. That's too high, so our answer is 35. Question 5. Complete the statement below to make it correct. And it's telling us that something times m equals 2m. Well, we've got 1m on the left hand side. We want to make it into 2m on the right hand side. Therefore, we multiply it by 2. 2 times m equals 2m. Question 6. Now, for the first time, we have a question which has more than one part. And although you can't see it on my screen, part C is worth 3 marks. So we have a total of 5 marks here. So well worth having a look at. Ben sells houses. The pictogram shows information about the number of houses Ben sold in each of the first 3 months of last year. So let's have a look. The year, we've got January, February, March, and we've got a key that one large square represents 4 houses. So, part A, write down the number of houses Ben sold in January. Well, if one square is 4, then that is 4, and another 4 there. That's only half a square, so that is only 2. Therefore, 4 plus 4 plus 2, in January he sold 10. In April, we are told he sold 11, and we have to show this information on the pictogram. So what are we looking at doing? We're looking at representing 11 on here. So, quite carefully, we need to draw one box here. That's going to be 4. Then we have another box which is going to be 4. Now, we need to fit 11, and if I draw another box, that would be 12. Now if we look at the way this is being done, in January a half a box is 2. In February there's a quarter of a box there, which is only 1. Now I need to show 3, so to do that I'm going to have to show 3/4 of a box. So it's going to look like that. So that is 4, that is 4, that has a corner missing, so it's only 3, so altogether we have 11. The final part tells us that he sold a total of 60 houses in the first 5 months of last year, so that's the total pictogram here. Work out the number of houses Ben sold in May. Well, we already know January was 10, February is 4 plus 4, and the little one there is 1, it's a quarter of 4, so that's 9. Then we've got 4 and 4 and 4, so that's 12. Well, let's just add up what he sold in the first 4 months. 9 plus 2 is 11, plus 1 is 12, carry the 1, 1, 2, 3, 4. So in the first 4 months he has sold 42 houses. By the end of May he sold 60, so 60 minus 42 means that in the month of May he sold 18 houses, and that will be your answer down at the bottom. Now 7, I'm going to do parts A and B separately just to make space. It says measure the length of this line. Now the problem is that my ruler and my screen are going to be different sizes to the actual exam paper that you've got, but the principle is the same. I take my ruler and I put the 0 right on the beginning of the line here, like that, and I look at the other end of the line. Now you can see here that that is on 85 millimeters. Your ruler might measure in millimeters or centimeters. Because mine is millimeters and it says give your answer in centimeters, I need to divide by 10, so 85 millimeters is 8.5 centimeters. Try to be as accurate as you can. The actual answer on the exam sheet is 8.7 centimeters. You are allowed to be a couple of millimeters either way, so they will accept anything from 8.5 to 8.9, but be as accurate as you can. Part B asks us to measure the angle X, so I'm going to need the protractor. So what we do first is put the X, the cross there on the protractor, right in the corner of the angle there. I'm then going to turn it round so that the top line of the angle is on 0. So those are my first 2 checks. Is the centre of the angle right on the cross on the protractor, and am I at 0 here? Both are true, so I need to measure my way around here. So if I go 0, 10, 20, 30, 40, 50, we can see that the angle here is 65, 66, it is 67 degrees, and in fact that is the correct answer on your exam sheet. And part C of question 7 says, in this space below draw a hexagon. And this is quite interesting. I've had a look at the answer scheme here. It does not say a regular hexagon. Now a hexagon has 6 sides, so if you were going to draw a regular hexagon it would look like that. But in fact, first of all, the rules say you are allowed to draw it by hand. Just be careful. And as long as you draw a 6-sided shape, so in other words 1, 2, 3, 4, 5, 6. That's an irregular hexagon, but it's perfectly good. It is a hexagon. If you want to draw the more regular type, I guess you'd have a go at something like that. But at the end of the day, as long as they can see a 6-sided shape, you'll get the mark. Question 8 has given us a graph. It says the points A and B are shown on the grid. Yes, they are, A and B. And first of all, we're asked to write down the coordinates of the point A. Well, coordinates are measured, and the brackets are already given us here, as the x coordinate. So first of all we go along here, the x coordinate is 2, so that's the first of our numbers. Then we look at the y coordinate, it's up here and it's on 1, so the coordinate is 2, 1. It then says find the coordinates of the midpoint AB. So midpoint AB means that we now have a line going from A to B. There are a number of ways you could do this. Possibly the simplest way with your ruler is to simply measure that line and find halfway along. That will give you the coordinates. You could also look at the actual movement of the line from A to B. So A has gone down 1, 2, 3, 4, 5, 6, and it's gone back 1, 2, 3, 4. So if that is 6, halfway down would be 3, and halfway back would be 2, and that would take you to a point right in the middle of the line there. And the coordinates of that point, well, x first, x is actually on the 0 line, then the y, that is on -2, so it's 0, -2. It then says, part C, on the grid mark with a cross the point with coordinates -4, 2. So again, starting from the centre here, -4, we go along the x line, -1, 2, 3, 4, brings us to here, and then it's +2, so 1, 2. That gives us a point there, and it tells us we have to label that as C. Question 9. Anil has a job as a driver. He is paid for each mile he drives, and he's also paid expenses. Okay, so 1 week Anil writes down the distance reading, or the mileage, on his car. We've got the start and the end. He's paid 47 pence for each mile he drives, and he's also paid expenses of £80. Work out the total amount that Anil is paid. So calculator time. So at the end of the week he has travelled 47,879. To find out how much he's travelled during the week, we need to subtract the mileage that was shown at the beginning. In other words, we're looking for the increase in mileage. So 9 minus 1 is 8, 7 minus 4 is 3, 8 minus 2 is 6, and then we've got 0 and 0. So he's travelled that week 638 miles, and we know he gets paid 47 pence. If we turn that into pounds, that would be 0.47, because at the end of the day we want the answer in pounds. So 638 multiplied by 0.47 comes to £299.86. So that's the amount he's claiming because of his mileage, but then we know he's got some expenses and he gets paid an extra £80, so we have to add that on top. So add those together, and 9 8s are 17, press the 1, put the 3, £379.86. Question 10. Anita throws a coin 3 times. Each time the coin can land on heads or tails. Okay, list all the possible outcomes. So she's throwing this coin 3 times. Let's sort of do this as logical as possible. The first possible outcome is that all 3 coins, H is heads, T is tails, all 3 coins could land on heads. So that will be heads, heads, heads. The second one could be heads, and the third coin could land on tails. So that's a possibility. It could be that she gets heads, then the middle one is tails, and the last one is heads. It could be that it's the first one that is tails and the second 2 are heads. Now let's change that round. I think it depends how your head sees this, but my other logic is to say, okay, it could be tails and tails and tails, or it could be that it's tails, tails and heads, or it could be tails, the middle one is the head, or it could be that the first one is the head and the second two are tails. So we've got everything from all three heads, all three tails. There are three situations where you could have two heads and a tail, with the tail being in different places. And there are three situations where you could have two tails and a head, with the head being in one of the three different places. And that's it. You have 8 different conclusions. Try to make sure in a question like this that you don't repeat any of them, or you may lose marks. Question 11. Majid has a spinner. He's going to spin the arrow. The arrow, here we go in the center here. The arrow can land on 1, 2 or 3. Majid said the probability that the arrow will land on 2 is 1/3, because the spinner has 3 sections. Is Majid correct? And you must give an answer. Now, don't write a book here, it's only worth 1 mark, but is Majid correct? So we can say Majid is not correct. And we have to say why. Well, the reason being, you can put it several different ways. If it was going to be 1/3, then the angle of all the sections would be the same. They would be thirds of the circle. Therefore, it is more likely that the arrow will land on 1 and 3 because they're bigger areas. Or you could say area 2 is 1/4 of the circle. We know that because there's a 90-degree right angle there, is 1/4 of the circle. So in that case, so the probability is 1/4. Okay, so think of that again. If the angle is 90 degrees, it is only 1/4 of the circle, so the probability that it will land in that area is 1/4. Or, had it been 1/3, then all these angles would have been the same, and the sizes of each area would be the same to make it 1 in 3 for each number. Okay, here comes question 12. Saira buys 24 bars of chocolate. 3/4 of the bars are white chocolate. The rest of the bars are milk chocolate. Each milk chocolate bar has a weight of 35 grams. Work out the total weight of the milk chocolate bars. So this question is dealing in the milk chocolate bars. Be careful of that. So first of all, let's look at the first part here. 2/3 of the bars are white chocolate. So if 2/3 are white chocolate, that means the other third must be the milk chocolate. So we need to find 1/3 of 24. So in other words, 24 divided by 3 equals 8. So there are 8 milk chocolate bars. Each milk chocolate bar has a weight of 35 grams. So that's 35 multiplied by 8. 8 times 5 is 40. Put the 4 up there. 8 threes are 24, plus the 4 is 280. So that's 280 grams. Question 13. We've got part A. Says simplify 2c multiplied by 3d. So we got the 2 times the 3. That's 6. There is a c and a d. There's nothing to multiply by either of them on the opposite side. Therefore, it is simply 6 times c times d. 6cd. Now, we've got a part B. It says t equals x plus 2y. X equals 3 and y equals minus 4. So what have we got? Let's write this down. T equals x plus 2y. Now, if we write this again, t equals, we know that x is 3, so we can put a 3 in there, plus 2 times y, that's 2 times minus 4. Okay, so if we do, using BIDNAS, this bit first, 2 multiplied by minus 4, that is minus 8. So we've got 3 plus minus 8. And that simply means 3 minus 8, which is minus 5. Question 14. On Monday, Lizzie cycled 36 kilometres in 3 hours. Okay, work out Lizzie's average speed. Well, if she did 36 kilometres in 3 hours, if we take 36 and divide it by 3, that means on average she did 12 kilometres per hour. Okay, that's okay. 36 kilometres, 3 hours, 12 kilometres an hour. Now on Tuesday, Lizzie cycled 36 kilometres, so that's the same distance, at an average speed of 16 kilometres per hour. So she's going faster. Lizzie says the total time she cycled on Monday and Tuesday was less than 5 hours 20 minutes. Okay, so we know that on Monday she did it in 3 hours. We are told that Lizzie believes she did the 2 days in less than 5 hours 20. So we need to know how long it took her on the Tuesday. Let's have a look at this. So if she did 36 kilometres at an average speed of 16 kilometres per hour, so distance divided by speed gives us the time, and 36 divided by 16 is 2.25 hours. Now be very careful, this is not 2 hours 20 minutes, this is 2.25 hours, and 0.25 is a quarter, so that is actually 2¼ hours, which is 2 hours 15 minutes. That's the tricky bit. If you do it with a calculator, you're going to get a decimal. So 2.25, it's not minutes, it's fractions or decimal amount of an hour. It's a quarter of an hour. So what have we got? We've got Monday was 3 hours. We've got Tuesday was 2 hours 15 minutes. So altogether her cycling time is 5 hours and 15 mins. So is that less than 5 hours 20 minutes? Yes, she is correct, because it is. It's 5 minutes less. Question 15 tells us that £3,500 is invested in a bank for 6 years. The bank pays simple interest at a rate of 2.5% per year. Simple interest makes it easy for us because it simply means that they are going to pay 2.5% of 3,500 each year, no accumulated interest from previous years. So we need to find out what is 2.5% of 3,500. So it would be 3,500 divided by 100, that gives us 1%, times 2.5. Get the calculator out, and that comes to £87.50. We are being paid that for 6 years, so we need to multiply that by 6. And £87.50 multiplied by 6 is £525. Exactly. And there's your answer. Question 16 says you can use this graph to change between ounces and grams. So it's a conversion graph. Let's see what we're being asked to do. Change 6 ounces to grams. Well, 6 ounces is at the bottom here. So what we're going to have to do is draw a line from the 6 grams line. I will be as accurate as I can here. Not so easy on this screen, but it's about there, and I need to go right up to the line. Again is there. I then need to measure or to mark across from the line across to the corresponding point on the grams. That is how we convert. So from 6 ounces up to the line and across. We need to look at the scale here, and in fact it's going from 150 to 200, so that's 50 in 10 steps. So each square is 5, so 155, 160, 165. That line there is 170. So that's the answer, 170 grams. Now, part 2 says change 1 kilogram to ounces. Now we've got a problem here because our graph only goes up to 300 grams. It doesn't go to a kilogram. Therefore we have to know that 1 kilogram equals 1,000 grams. We need to make up 1,000 grams. There's a number of different ways we could do this. What we could do is we could convert 100 grams, so draw a line across and down from 100, and then multiply the answer by 10 to get 1,000. You could do 200 grams and measure across here and down. That would be 200 grams, and then you could multiply that by 5, because that would also give you 1,000. In fact, the way I'm going to do it is different again. I am going to measure 250 grams, and then I'm going to multiply that by 4, because again that will give me 1,000. So let's do that. 250 grams, again being as careful as I can. No, I'm slightly high there, hang on, let's say about there. That's 250, takes us to that point there. I then need to carefully come down from there. Hopefully you're going to use a ruler and maybe be more accurate than me. Now then, let's have a look at this scale. This is going from 8 to 10. That's only going up 2 on the steps, so it's going to be 8.1 to 8.2, 8.4, 8.6. That's going to be 8.8. Now that's for 250 grams, so I've then got to go 8.8 and multiply that by 4, and that gives me an answer of 35.2 ounces. OZ for ounces. I will say that the answer in the mark scheme is exactly 35 ounces, so I'm slightly out because of the difficulty in getting my line exact, and in fact they do give you a little bit of leeway either side. So again, be as accurate as you can. You do have a small amount of leeway when drawing your lines. Question 17. Right, this is really difficult for me to show you on the screen, but let me explain what I've done. I've already marked this out. Here's a triangle, A, B and C. We are looking at a region, an area within the triangle, which is all the points inside the triangle that are. So we are looking for an area in the triangle that satisfies these two conditions here. One of those conditions, it is less than 4 centimeters from A. So what you need to do is take a compass and put the point on A and draw a circle where the radius is 4 centimeters. So that means if I come back to this triangle now, any part of the triangle that is less than 4 centimeters from A is any part within this sector of the circle here. All these points within here are all closer than 4 centimeters to A. However, we've got a second condition. It says and closer to C than B. So what I've done here is I've measured the distance C to B. I found a halfway point and I've drawn a perpendicular bisector. In other words, a line at 90 degrees to the line CB. This means that all the points that are closer to C than B are all the points that are in this part of the triangle. They are all nearer to C than they are to B because they're on the left hand side of this line. So now I have to satisfy both of these conditions. I have to look at points which are on the left hand side of this line and inside this circle. So it's going to be this area here. Now if you try this on the past paper, yours may look slightly different to mine because your 4 centimeter circle may look different. The measurements will be different on your paper, but that's the principle behind it. So just to summarize again, we need all the points that are within 4 centimeters. So we've drawn a line that is 4 centimeters away from A. That gives us this area. We then want all the parts that are closer to C than B. So we draw a perpendicular bisector and look at the area that is closer to C. And this area in the center satisfies both of those. So that area is our answer. Question 18. Mrs. Simpson has organised a school trip for 66 children. The total cost of the trip was £1,800. The school paid 56% of the total cost, and the rest of the cost was divided equally between the 66 children. Work out how much money each child paid. So first of all, we need to know what is 56% of the 1800. And we can do that a few different ways, but with a calculator, the easiest is 1,800 multiplied by 0.56. Multiply by the equivalent decimal. So if we do that, we get the answer 1008. Now that's the part that the school is paying. So if we take 1,800 and take away 1,008, that means that the children are left with £792 to pay in total. 792, we are dividing that equally between the 66 children, and that means that they pay £12 each. Question 19, part A. Work out the value of that. Okay, this is a question that is supposed to be done completely on a scientific calculator, because it says write down all the numbers on your calculator display. My apologies, I do not have an online calculator that I can use to show you this, and in fact, in honesty, you really need to know how to operate your own personal scientific calculator. There are guidelines, you can read videos, teachers can help you with the basics, but you need to know your own calculator and how to input something as complex as that. So that's something I can't help you with. However, if you do master that, the answer that you are going to get is going to be 0.5170189759, and it does say write down all the numbers, so put the whole number in. If you've got that far, it then says write your answer to two significant figures. So how do we do that? Well, we look along the number until we come to a digit that is not a 0. So 5 is your first significant figure, 1 is your second significant figure, but don't forget when we're writing significant figures we have to take the rounding rules, and the next number is a 7. So your answer is going to be 0. First significant figure, a 5, and because of the rounding rules, second significant figure is the 2. Question 20. ABC is a right angled triangle. Work out the length of CB and give your answer to 3 significant figures. So we are working with Pythagoras, and Pythagoras says that AB squared plus CB squared equals AC squared, but we've got AB and CA, so we're going to have to use CA squared minus AB squared equals CB squared. So CA squared is 19 squared. 19 times 19 is 361. Minus AB squared, that's 10 squared is 100. So 361 minus 100 is 261. Now that is CB squared, so we then need to find the square root of 261, and the answer 16.155494, and it goes on. But if you look back at the question, it says give your answer to 3 significant figures. So as we did previously, 3 significant figures, well, the first significant figure is the 1. So the first significant figure is the 1. The second significant figure is 6 point. The third significant figure would be the 1, but again, the rules of rounding, the next number is a 5, so that rounds the 1 up to a 2, 16.2 centimeters. I'm going to do question 21 in 2 parts because they are quite different. 21A says write 90 as a product of its prime factors. So we're going to start with 90 and we're going to break it down through its factors until we get the prime one. So the trick is, first of all, just find 2 factors. 90, well, I'm going to use 10 and 9. And then I'm going to break these down and find 2 factors for each of these. 10 is 2 times 5, and 9, of course, is 3 times 3. Now, that's it, because each of these 4 numbers are prime numbers, and they are all factors of 90, so they are the prime factors. And I would write this by putting them in order: 2 times 3 times 3 times 5. And you could, in fact, put 2 times 3 squared times 5, but either of these would be an acceptable answer. And then we have part B. It says A equals 2 squared times 3, B equals 2 times 3 squared. Write down the lowest common multiple of A and B. I can't help but feel this looks more complicated than it needs to be. Let's just have a look at this. We know that A is 2 squared times 3. So 2 squared is 4. 4 times 3, A is simply 12. B, on the other hand, is 2 times 3 squared. Well, 3 squared is 9, so 2 times 9 is 18. So to find their lowest common multiple, we need to look along the 12 times and the 18 times table. Well, the 12 times table is 12, 24, 36, 48, 60. Let's see if we've gone far enough. The 18 times table is 18, 36. We're there already, because the common multiple of 18 and 12, the lowest one, is 36. So that's your answer. Question 22, and I think this question is another one that appears horrible when you first look at it, but you just need to get your head sorted around it. Let's read it carefully. The number of hours, that's H, that some machines, just some machines, take to make 5,000 bottles is given by H equals 72 over N, where N is the number of machines. So, in other words, to work out how many hours it is needed to make 5,000 bottles, you take 72 and you divide by the number of machines. So, on Monday, 6 machines made 5,000 bottles. So that would be, the time in hours would be 72 divided by the number of machines, which is 6. So it's 72 divided by 6. Well, 72 divided by 6 is 12. So on Monday it took 12 hours. On Tuesday, the number of hours was 72 divided by 9 machines. So 72 divided by 9 is 8. 9 eighths is 72. So Monday it took 12 hours. Tuesday, because there were more machines, it took 8 hours. And it says here, the machines took more time to make the bottles on Monday than Tuesday. How much more time? 12 minus 8. 4 hours more. Question 23. Bit of a mind bender and a few ways to do this, but let's have a look. There are only red discs, blue discs and yellow discs in a bag. Red, blue, yellow. There are 24 yellow discs in the bag. Mel is going to take at random a disc from the bag. The probability that the disc will be yellow is 0.16. Okay, so that's probability. Then we've got the number of red discs to the number of blue discs is 5 to 4. Work out the number of red discs in the bag. As I said, a few ways to do this. I'll do it one way. Hopefully it will make sense. So first of all, probability. If the probability that the disc that Mel takes out being yellow is 0.16, then if we say, well, the probability she's going to take a disc at all is 1, take away the probability that it's going to be yellow, which is 0.16, you end up with the probability of it being red or blue is 0.84. Okay, so 0.84 it could be red or blue, 0.16 that it's going to be yellow. Now, we have a ratio here. We know the ratio of yellow to red and blue. So if I write that down as a ratio, it's 0.16 to red blue 0.84. Now into that ratio I can put the number of yellow discs. There are 24. So if I take 24 and divide by 0.16, that will give me the multiplier on this side. So 24 divided by 0.16 is a multiple of 150. So on this side I'm going to apply the same multiple. I'm going to put 0.84 times 150, and the answer I get there is 126. What have I done? Well, by looking at the probability of taking out a yellow ball compared to the probability of taking out red blue, which is 0.16 to 0.84, I've applied that ratio by putting in 24 yellow discs, working out the multiple, and using the same multiple on the red and blue. It tells me that there are 126 red or blue balls. That takes me a step further to my answer now, because I now need to work on the red and blue ratio, because I know the red to blue disc, the red to blue ratio is 5 to 4. In other words, there's a total of 9 parts. I know there are 126 of them, so 126 divided by 9 equals 14. So I've worked out one part of the ratio. One part of the ratio is 14. The question asks me how many red discs there are, so it's 14 multiplied by 5. 5 fours are 20, 2 up there, 5 times 1 is 5, and my answer is 70 red balls. Question 24a. It says complete the table for values of y equals x squared minus x. So what do we do here? We've got a box with all the values of x and the values of y. 3 of the values of y have been given to us. We need to work out the ones in the empty boxes. So we look at the value of x and we put it into this little equation here. And I can see there are minuses everywhere, so we're going to have to be careful. So x is minus 1. So first of all, it's x squared. So that's minus 1 squared. 1 times 1 is 1. Minus times minus is a plus. So minus 1 squared is 1. It then says minus x. So it's 1 minus x, which is 1 minus minus 1. And if you're taking away a minus, you're adding. So it's actually 1 plus 1 is 2. The next one we need to find is where x is 1. So we've got 1 squared, x squared, 1 squared is 1, minus x, so 1 minus 1 is 0. We've then got x is 3, so we now have x squared, 3 squared is 9, 9 minus 3 is 6. So that completes the box. For part B, we now have to draw this graph. So let's plot these points. We've got minus 2, 6. So minus 2, and up here to 6, our first point is there. We've then got minus 1, 2. So minus 1 and 2. We've got 0 and 0. So that's right on the line there. We've got 1, 0. So that's 1, 0 is there. 2, 2 is 2 and 2, which is there. And 3 and 6, which is up here. So we need then to draw the line. This is incredibly difficult on this screen, and it's going to look a little bit rough, but what we are looking for, and the best way to do this, is just carefully draw a curve which follows the path. Again, it's incredibly difficult to control the pen to do this, but you need to be looking at a line as smooth as possible which connects these points. My apologies that that looks a little wonky and a little rough, but it's difficult with this software. So that's part B. We are then using your graph to find estimates for the solutions of the equation x squared minus x equals 4. Now if you look at this x squared minus x equals 4, it is the same thing. X squared minus x equals y. So actually you are looking at y being 4. So y is 4 along, let's put it in as a straight line here. Y is 4 along this line here. Y equals 4. So we are looking at the points on the graph where our drawn graph meet y equals 4. So we are looking at here and here. Okay, and if I can just put those in red a little bit more accurately. Again, my graph is incredibly difficult to draw. A little bit more carefully yourself. And then you're going to come up with 2 readings for x. On my page it's about here, so it's 2.6, and here it's about minus 1.5. 7. And in fact, having just taken a look at the answers, they are effectively about bang on the answer that's expected in the exam sheet. Question 25 has all sorts of things on here. Andy, Luke and Tina share some sweets in the ratio 1 to 6 to 14. We've then got Tina giving 3/7 of her sweets to Andy, and then 12.5% of the rest of her sweets to Luke. And then she says, now we've all got the same number of sweets, and we've got to figure that out. So let's have a look at this. We've got Andy, we've got Luke, and we've got Tina. And their ratio is 1 to 6 to 14. Now that means that the total number of parts in the ratio is 21. 14 plus 6 plus 7. So the total number of sweets must be 21, or a multiple of 21, for this ratio to work. I am going to leave it and assume that there are exactly 21 sweets. So at the moment, Tina has 14, Luke has 4, and Andy has 1. Okay, let's look at the first part. Tina gives 3/7 of her sweets to Andy. So we are looking for 3/7 of 14. So that's 14 divided by 7, which is 2, times 3, which is 6. So that means that Tina is going to give Andy 6 sweets. So Tina to Andy equals 6. So what do we have now? That means that Andy now has 6 extra, so he's got 7. Luke hasn't been affected by that transaction, still got 6. Tina has 14 minus 6. Tina now has 8. So let's move on to the second part. Tina then gives 12.5% of the rest of her sweets to Luke. Well, she's got 8 sweets left, so to find 12.5%, it will be multiplied by 0.125. And 8 times 0.125 equals 1. So she's going to give 1 sweet to Luke. So now we've got, Andy's still got 7. Luke gets an extra 1. He's got 7. Tina's just given that 1 away. She's got 7. Is Tina correct? Yes, she is. Question 26 is telling us that the shape here, ABCD, is a quadrilateral. It says all angles are measured in degrees, and we're to show that it's a trapezium. So what do we know about the qualities or the properties of a trapezium that makes it a trapezium? Well, we need to show that this and this, the two sides, top and bottom, are parallel. A trapezium has one set of parallel lines. How do we do that? Well, we look at the angles. In fact, what we need to know is that for a trapezium, a pair of co-interior angles, which is either this pair or this pair, have to add up to 180. If they do, it proves that it's a trapezium. So we need to know that these two, let's use the two on the right for no particular reason, we need to know that these two add up to 180. So first of all, we need the value of x. Now of course in a quadrilateral all interior angles add up to 360, so all these angles add up to 360. So if we add them all together, and we do that by collecting the terms, so how many x's do we have? We've got 4x plus 4 here, that's 8, plus another 3x here, that's 11x, and another 2 here, that is 13. So we've got 13x. Then we've got some numbers. We've got plus 15, plus 8, that's 23, minus 3, that's 20, plus 15, that's 35. So plus 35. So 13x plus 35 equals 360. Let's work this out then. Bit of moving around. 13x equals 360 minus 35. So 13x equals 325. So x equals 325 divided by 13. X equals 25 degrees. Okay, let's just draw a line down here. We now know that x is 25 degrees. If we substitute that into here, it should equal 180. So if we add these two angles together, 4x plus 3x is 7x, plus 8 minus 3 is plus 5. So 7x is 7 times 25. So 7 times 25 is 175, and we've still got the plus 5 there. 175 plus 5 is 180 degrees. Therefore, the angles at C and D do equal 180 degrees. So yes, it is a trapezium. Question 27. We've got two similar isosceles triangles. So similar in that the angles are the same and the ratio of the sides are the same, and we need to work out DE. A lot more straightforward than the last question. Look at the ratio here, 6 to 1.5. 6 over 1.5 is 4. 6 is 4 times 1.5. Therefore, to find DE, we take 8 and we divide by 4, and we get the answer 2. And finally, question 28. We have a table with grouped data. The table shows the information about the weights of 120 oranges. So we have groups. We know that 34 of them are weighed between 50 and 100, or rather larger than 50 and smaller or equal to 100. The next group over 100, smaller or equal to 150, and so on. It says, part A, find the class interval that contains the median. Well, the nice thing about group data is these weights are kind of in order. They're certainly in order as far as the grouped data is concerned. So we need to find out how many there are altogether and find the middle one. We already know that there are 120 oranges, so we need to start at the beginning and find the median, which is going to be between the 60th and the 61st orange. So what box does that fall in? Well, the total up to here is 34. Add 29 is 63. That's already above the middle. So the median is in this group here somewhere, which is that group there. So write down that group in your answer box, and that's the median. Now for 28b, I've written down all the answers here because it takes a lot to explain. It's asking us to calculate an estimate for the mean weight of the 120 oranges. So we want to know the average weight of each orange. Now we have a problem here that we do not know, within each of these groups that we've got here, we don't know the individual weight of any orange. So for instance, in this first group, we know there are 34 oranges, and we know what the range of their weights are, but not each individual one. So what we do is we assume, this is where the estimate comes in, we assume that each of them is at the middle weight. So between 50 and 100, the middle is 75. So in other words, we're working out an average weight by estimating. Some will be higher, some will be lower. So what we do is we take the 34 and multiply by 75. Similar, the second group between 100 and 150, the midpoint is 125, the next one 175, and so on. And we multiply those midpoints by the number of oranges in each group. This gives us an estimate of the total weight within each group. So if we add all those together, we get an estimate of the total weight. That comes out at 18,200 grams. Once we've got the total, to find the mean, we divide by the number of oranges. We know that's 120. So we get 18,000 divided by 120, and the answer on your calculator is 151.6666 recurring. We're asked to give your answer to 3 significant figures. So the first significant figure is the 1, then the 5, The third significant figure is the 1, but because there's 6 we round it up so it becomes 152. 152 grams per orange. And that's it, the end of the paper. I hope you found that useful. If you did, please do all the usual things. I'd appreciate if you liked and shared and subscribed. And finally, good luck with your exams. Thank you.